This is another video from Chapter 5. This has to do with binomial probability distributions. And again, I just want to give you an overview of binomial distributions and then let you watch some of the other videos with examples. The idea of a binomial probability distribution is that our outcomes have to belong to two categories only, such as acceptable or defective, yes or no, survived, died, and so on. So to be a binomial probability distribution, we have to meet all the following requirements. The procedure has a fixed number of trials. The trials must be independent. In other words, the outcome of any individual trial doesn't affect the probabilities in the other trials. For example, if you're doing something like pulling names out of a hat, if you don't replace the names after you pull them out, then the trials wouldn't be independent. In the second draw, you wouldn't have as many names as you did in the first draw. Each trial must have all outcomes classified into only two categories. And in statistics, we refer to these as success and failure. And the probability of a success has to remain the same in each trial. Here's what our notation looks like. The S is going to stand for success and the F for failure. And these will be defined just by the problem, or by you if you're the one that's designing the probability distribution. Success could be a negative outcome. It just depends on how we define it. A small p will denote the probability of a success. Q in some places will denote the probability of a failure. So our probability of success is going to equal P. Our probability of a failure on any trial is going to be Q. Remember that these would be complements, so that would be the same as 1 minus P. For our fixed number of trials, N will stand for the number of trials. X is going to denote the number of successes in N trials. So X is going to be our random variable in this case. It can be any whole number between 0 and whatever N is. P again is the probability of success in one of the trials. Q is the probability of failure. And capital P of X denotes the probability of getting exactly X successes in the N trials. Some important hints for binomial distributions. Be sure that X and small p both refer to the same category, which you're calling a success. If a success is that you got heads on the coin flip, make sure that P stands for the probability of getting a head, and X stands for the number of heads. Or if success is that you pull a red M&M out of the bag of M&Ms, then P would be the probability of getting a red M&M, and X would be the number of red M&Ms that you pulled out in however many trials that you're doing. There are certain cases, if the numbers are big enough, that we don't need to worry about replacing the values because the difference between the two is so small that it doesn't matter. So for example, if you had a huge bag of M&Ms that had 400 M&Ms in it, then in that case it wouldn't really matter if you replaced the M&Ms each time. It wouldn't make a big enough difference to be significant. This is the most important part of this video because in this part I'm going to tell you what I don't want you to do. We're going to talk about 3 different methods for finding binomial probabilities. And this first one, again, this is a really difficult formula to learn and it's complicated, and I'd really rather you didn't try to use this one. The time that you're going to spend learning how to use this probably isn't worth it, especially when we have lots of technology that can help us with this. So I'm just showing you this so that you know what some of the other videos are talking about when they show you this formula, but I don't recommend that you do this. What I'd rather have you do is use technology. There are several different options for doing that. One of them is StatCrunch. You will see more of this in the tech assignment for this chapter. Another way is to use a TI calculator. Again, there's another video about how to use these two functions, binomial PDF and binomial CDF. The first one gives the same probability as the example over here, so it gives the probability of exactly 3 successes. The second one gives the probability of 3 or fewer successes. Another thing that you can use is Excel if you have access to that. And again, there are 2 different versions of the formula in Excel. The first one, where you have a 0 at the end, gives you exactly the number. The second one, where you use a 1 at the end, gives you that number or fewer. So these two values correspond to the values that were on the TI calculator on the last slide. Okay, method 3, if you don't have access to a TI calculator or to Excel or to StatCrunch, say if you get to take your exam over this unit and you don't have a TI calculator, you will have access to a binomial probability table. If you think you're going to have to use that on the test, then you should try using it for some of the homework problems. So if you're trying to use a table, the table will show you the value of n, so the number of trials, and then there will be another column that will give you different x values. At the top, column headings will give you different values for p, then in the different cells you'll have the probabilities. One of the big problems with using a table like this is that usually the values for p are very limited. So you can only find very specific probabilities using a table. One other thing about binomial probabilities, for these to find the mean, variance, and standard deviation, the formulas are actually easy. So these are formulas that I do suggest that you use. Now these were the ones for any discrete probability distribution. But here are the ones for a binomial distribution. Notice that the mean is only n times the probability of success. That's really easy. The variance is just n times p times q, or that's the same as n times p times 1 minus p. And once you've got the variance, then you can take the square root of that to get the standard deviation. So these are ones that I do suggest you use just because they're so simple.